Hello, ConTech community. My name is Tal Friedman, and I'm an architect and engineer, founder and CEO of Foldstruct. And it's a real honor for me to be here at the Construction 4.0 event. I think it's really a one-of-a-kind event that merges between so many different fields and stakeholders. And for that reason, I'm really looking forward to sharing new concepts with you guys. So I'm going to be talking about the future of merging design and fabrication together, what this means as an industry, and show a little bit of examples of where and how this is happening all over the world. So I hope you enjoy the show. And without further ado, I'll move to the presentation. So as the title suggests, we're going to be talking about going from design to manufacturing and back. The AI revolution in construction has begun. But before we talk about the future, I'd like to talk about the past for a minute, and I'd like to look at the vision we had for robotics. So back in the 60s, we were talking about this kind of utopia slash dystopia, depends who you ask. And it was very clear that our world is going to change drastically. If we look at that vision and compare it with 2021, we can see here that we are at a stage where robotics have completely shifted our view of reality. And it's fair to say that they've even pulled the rug under our own feet, where we have all this technology in our hands, but we still don't know what to do with them. So what does this mean for the built world, and how can these great Boston Dynamics robots help us actually build a better world? So if we talk about the demand right now, we're seeing a global demand in advanced buildings. Iconic, sustainable buildings are showing great value and ROI for investors. And everyone's talking about how to move to buildings like this. However, with all this optimism and this trend, when we look under the hood of these buildings, we see that they are completely unfeasible for mainstream construction. In fact, 99% of the buildings look much more like this. They are too expensive to build, they take too long to build, they're too polluting and too dull on a wellness and architectural level. If I should quote Einstein, I'd say that the definition of insanity is to do the same thing over and over again and expect different results. And that is, in fact, what we are doing in the world of construction. If we look at the goals of the industry, we're talking about millions of buildings that will be built and renovated over the next couple of years. And I say that number again, millions of buildings, where we know that 40% of the world's CO2 emission is created by the construction industry. Combine those two together and you understand why tens of billions of dollars are being spent on energy reduction programs, because we are simply not building efficient enough. The main reason for that is because we're still relying on manual process, and we're relying on inherent constraints. When you're designing for the human hand, you are designing for the time and the energy restraints of the human worker. And of course, you will always be limited. So when we want to look at other industries and learn what they've done, we have to really look into the age of a smart factory and how to move away from this kind of manual labor into a much more unified approach. But of course, then we have to ask how to talk to a machine, because if we want to produce with machines, we need to learn how to design for them. And in this talk, we're going to talk a little bit about this field called DfMA, or design for manufacturing, and what this means for an industry. So automation, of course, is the key. We know that doing this, we can save design fees, engineering fees, all the way to actual fabrication fees. And we're seeing these numbers everywhere we look and in every industry, which has already gone through that transformation. One of those, of course, being the car industry. If we look at a car in 1921 and a car in 2021, we will see a 10 times multiple, in how cheap it is and how fast it is and how green it is. So this actually led to a transformation of a car being, a very, very high-end, I would say, luxury into an everyday commodity. And, enough has been said about the effect on the built environment, but we're going to look at the industry and see how they reached these goals and why the construction industry is so far behind in those terms. So what they had to do was basically bridge the gap between design and manufacturing, taking into account that cars are repetitive in nature. Robots were a very, very efficient way in automating processes. Of course, it started with the assembly line of Henry Ford, but if you can create an assembly line for people, you can also do the same for robots. But the main revolution was not actually in the manufacturing, but in the design for manufacturing. And that's exactly what we're going to focus on. So going from part design to design for manufacturing and assembly. In the industry, as I mentioned, this is referred to as DfMA, and it is completely revolutionizing the way people plan because we no longer have a representation of geometry in parts, but we are taking into account the manufacturing, the little screw level. So everything is basically a digital twin from design stages. So I was talking about pure geometry, and unfortunately, this is where we are in construction today. We still plan drawings, so all BIM software are essentially geometry platforms that draw what could or could not be a building, and we'll only know that at a much later stage as we go through what I call the domino effect. We start with the design, we move to the engineering, fabrication, and sourcing. In this process, we can never go back. And I think this is the big difference between design for manufacturing and the design we have today. So we need to move from the domino effect into the butterfly effect, where design and manufacturing for assembly are combined, so that when we make a change in the material, that will already affect our engineering and our design retroactively. So thinking of this as kind of a parallel universe for design where we can go back and forth and we don't have to create the same linear process over and over again is the key to AI optimization. Now, of course, it's not fair to completely compare cars and buildings because, as I mentioned before, cars are repetitive in nature. A single car model can be produced tens or even hundreds of thousands of times, where not all buildings are alike. So it means that we have to think of a building as comprised of many repetitive elements, but the building itself is not repetitive. Now, many people have tried to replicate buildings, but we know what that led to. So we need to think of a building as an assembly of parts, maybe something more like IKEA in nature. And I think that will create that bridge between the design and manufacturing. So here's an example of a project that tries to make best use of prefabricated elements and then stack them one on top of the other. That's one approach. Another approach, which we see by big architects in New York, is to create a hybrid approach. Now, this hybrid approach takes modular elements and combines them together with these freeform elements in order to combine a very, very iconic building in the heart of New York, which has since become a world landmark. Now, I'm going to talk a little bit about what we do at the office. And what we do is take these construction methods and try to rethink them and try to create new possibilities of what could be if we use them a little bit differently. So here is a modular system. And we want to ask how to go from a sketch to a digital twin in a few clicks and feel that magic moment of going from a sketch to reality or from a vision to a sketch. I think that's what triggers architecture in general. So I'm going to show you an example of how we move from this in a couple of clicks to something like this. Now, this building is one that we're working on right now, where we started out with a very basic sketch and we had to take that sketch as the reference. So what we did was a complete unified flow that took the very same model and then just started adding more and more layers on top of it until we arrived at something like this. And this is all done in an automated way. Here's another example of something we're doing with mass timber, which again is a modular system where we said, what if we stack them up a little bit differently? Does modular construction really have to be so modular in its complete approach? So this is an example of a pavilion that was done using a very industry standard material called a Lucobond. We took a 4mm thin sheet and said, what if we remove all of the substructure using digital tools and create a unified thin shell structure that would be about 10 times cheaper to produce than if we actually had those metal bars around it. And here you can see the example. We managed to reduce the labor and time by about 3 times, create a complete new system and method for construction that we are exploring in different applications like facades and other types of thin shells. Another project we're working on is getting an input where the developer wanted to test the design on a project that they had, and in return they got this from us, working on the very same model in just a couple of clicks. And of course, going from that model, we already go to robotics, to fabrication, and create a unified process. So if there's something I want you to take from this conversation, and here you can see some of the works that we do in the background, is that modular construction does not have to be repetitive. It does not have to be boring. Robotics do not have to be expensive. The opposite is true. When we learn to use repetitiveness together with customization together, we can provide a complete new way of thinking. We can reduce costs. We can improve the performance and design of buildings, and we can get to the goals of the construction world. So I want to really thank you for listening to this talk. And if you have any questions, feel free to reach out. Enjoy the rest of the Construction 4.0 event, and I wish you all the best. Thank you very much.